In this lesson, we will examine roots other than square roots. Now to set this up, it's important to note that the square root of a number can also be written this way, where the 2 here tells us that we are looking for a number such that when it is raised to the power of 2, the result will be 49. In fact, there was a time when this was the notation used for square roots. In this example, the square root of 49 is 7, because 7 to the power of 2 equals 49. Similarly, the square root of 100 can also be written as the second root of 100. This evaluates to be 10, since 10 to the power of 2 is equal to 100. We can now take this concept and extend it to other roots, such as this one. This expression is read as the third root of n, or the cube root of n. The definition of this is as follows. The cube root of n is a number that, when cubed, equals n. So, for example, the cube root of 8 is equal to 2, since 2 cubed is equal to 8. Similarly, the cube root of negative 125 is equal to negative 5, since negative 5 cubed is equal to negative 125. Now notice that although we cannot find the square root of a negative number, we are able to find the cube root of a negative number. We will discuss this shortly. Now, in general, we can say that the rth root of n is a number that, when raised to the power of r, is equal to n. So, for example, the fourth root of 81 is equal to 3, since 3 to the power of 4 equals 81. Similarly, the fifth root of 100,000 is equal to 10, since 10 to the power of 5 is equal to 100,000. Okay, now let's take a closer look at certain types of roots. To begin, odd roots are roots such as the third root, the fifth root, the seventh root, and so on. And even roots include the square root, the fourth root, the sixth root, and so on. Now, when it comes to odd roots, one property is that we can find the odd root of a negative number. Another property is that the odd root of a negative number will always be negative. So, for example, the fifth root of negative 32 is equal to negative 2, since negative 2 to the power of 5 equals negative 32. Now, another property is that an odd root of a positive number will always be positive. Now, when it comes to even roots, one property is that we cannot find the even root of a negative number. So, for example, the fourth root of negative 81 has no real value. Another property is that the even root of a positive number will always be positive. So, for example, the fourth root of 625 is 5, since 5 to the power of 4 is equal to 625. Now, an important underlying property here is that all roots have at most one value. So, for example, the fourth root of 16 does not have two values. The fourth root of 16 has only one value, it equals 2. Now, at this point, I'd like to talk about the relationship that exists between the roots of numbers and the powers of numbers. I will begin by stating that the square root of x is equal to x to the power of 1/2. To prove this, we can use the fact that if x is greater than or equal to 0, then the square root of x times the square root of x is equal to x. To begin, let's rewrite the right-hand side as x to the power of 1. Now, to prove that the square root of x is equal to x to the power of 1/2, we can let the square root of x equal x to the power of k, and then prove that k must equal 1/2. Now, if the square root of x equals x to the power of k, we can take our equation here and replace each square root of x with x to the power of k. From here, we can apply the product law, which says we can simplify the left-hand side by adding the exponents to get x to the power of 2k. Now, if x to the power of 2k is equal to x to the power of 1, then we can conclude that 2k must equal 1. And if 2k equals 1, then k must equal 1/2. So we have now proven that the square root of x is equal to x to the power of 1/2. In general, we can say that the nth root of x is equal to x to the power of 1 over n. So, for example, 36 to the power of 1/2 is the same as the square root of 36, which equals 6, since 6 squared is equal to 36. Similarly, 64 to the power of 1/3 is equal to the cube root of 64, which equals 4, since 4 cubed is equal to 64. Finally, to evaluate 128 to the power of negative 1/7, we will first apply the negative exponent rule and rewrite this as 1 over 128 to the power of positive 1/7. From here, 128 to the power of 1/7 is equal to the 7th root of 128, and this is equal to 2, since 2 to the power of 7 is equal to 128. So 128 to the power of negative 1/7 is equal to 1/2. Okay, let's summarize. In this lesson, we learned the general definition of roots. We learned that a root will have at most one value, and we learned the relationship between roots and powers.